In this video, we're going to look at one statistical question. Are standing pulse rates generally higher than sitting pulse rates? But we're going to address this question with two different experimental designs, an independent groups design and a paired design. So I know that you're super disappointed that we're not in person where I could have you actually participate in this experiment. People love it when I make them stand up and sit down. But we're just going to use the data from last year. So let's start with an independent groups design. So with independent groups, as it sounds, the groups are independent, so there's separate people in the two groups. So each person is randomly assigned to one of the two groups. So in this case, each person is randomly assigned to either sit or stand. And it's not the same people in the groups. There's no real connections between the people in the two groups. And at the end, we're going to compare the average heart rates to see if the people who were randomly assigned to stand have higher heart rates on average. So this is what the data set would look like. I'm just showing it here for 3 different people, but obviously you can imagine having data from the whole class. So for every person that's in the data set, they're doing just one of the treatments, either sitting or standing, and we're measuring one quantitative value, what their heart rate is. And in this parallel box plot, you can see how the data came out. So standing heart rates do tend to be a little bit higher. If we compare the medians there, we can see that standing heart rates tend to be higher on average. But there's also a lot of overlap here. So there's some people in the standing group who have heart rates that are lower than people in the sitting group. So there's a lot of overlap between the distributions. So with this much overlap, is there enough evidence to say that there's actually a difference between standing and sitting heart rates? Another way we could ask the question is it possible that just sort of by random chance of who got put in the standing group and who got put in the sitting group, that we ended up with this difference and it's not actually real? So to answer that question, we need to do a hypothesis test. So we're going to state the null. We could do it as the two means being equal to each other. I'm going to state it here as a difference. So the mean for standing minus the mean for sitting. And the null hypothesis would say that those are actually equal, right? That it happened in this sample just by random chance that standing was higher, but in the long run they would actually be equal. The alternative, the thing that we're trying to show, is that standing is higher than sitting. In other words, if we're arranging it this way, that the mean for stand minus the mean for sit is greater than 0. So I analyzed this data in JUMP. I'll show you how to do that in a later video, but for now we can just interpret the values that are here. So we have a t-statistic of 3.4, that's pretty large, and a p-value of 0.0006. So that's smaller than most of the alpha levels that we would usually see. So with a large t-statistic and a small p-value, we can say that this evidence gives us strong evidence, right? When the p-value is small, we have strong evidence to conclude the alternative. And in this case, the alternative is that standing heart rates are higher on average. So obviously not for every single person, but on average, standing heart rates tend to be higher. So that's one possible design that we could use to answer the question. That's called an independent groups design because the people who are standing are totally separate and independent of the people who are sitting. A paired design is different, and it's pretty much just like it sounds. The data are going to come in pairs. So in this case, the way we get the pairs is by measuring each person twice. So each person sits and stands in this study. And if everybody's doing both, how does the random assignment come in? The randomness is that the order is randomized. So we don't want everybody to sit first or everybody to stand first because there could be something just about the time that makes everybody's heart rate higher the first time or higher the second time. We don't want that to get in the way, and so we're going to randomize the order. And then the analysis is going to be different too. For a paired design, we're going to analyze the differences for each person. So let's start by looking at how the data are set up. So instead of having just one measurement per person, now we have 2. For each person, we have their standing heart rate and we have their sitting heart rate, and we're going to calculate a new column of differences. So 76 minus 70 is 6. So that means for this person, their standing heart rate was 6 beats a minute faster than their sitting heart rate. For this one, it was 8. And for this one, their sitting heart rate was actually higher. And so this one's going to be a negative number. 64 minus 72 is -8. So the benefit of this is that it's easier to compare, right? Person 1 tends to have a heart rate that's faster than person 2, whether they're standing or sitting. But by comparing person 1 to themselves, it's a lot easier to see the difference. And the difference is actually all we're going to use here. We're going to ignore the standing and the sitting heart rates, and just the differences are going to be used as data. We're getting rid of the natural tendency for someone to have a high or low heart rate, and we're just comparing that person to themselves by looking at the differences. So if we look at the graph here, it's a lot more clear than last time that standing minus sitting is usually a positive number, right? If we look at 0 here, we can see that for most people, their standing heart rate was higher than their sitting heart rate because most people had positive numbers. And without counting, I can't look at the exact percent, but I do know that there's 3 sections of my box plot. So I can say that over 75% of people had standing heart rates that were higher than their sitting heart rates. So that seems pretty convincing, right? If over 75% of people have standing heart rates higher than their sitting heart rates, it does seem like there's a tendency for standing heart rates to be higher. So it looks more convincing, I would say. Let's actually do the test though. So when we go to write our hypotheses now, instead of writing 2 separate means for our separate groups, remember we're really just analyzing the differences here. So I'm going to write this as mu of the differences, the mean of the differences, and the null hypothesis would be that on average those differences are 0, and the alternative would be that standing minus sitting tends to be positive. So that's how we're calculating here, standing minus sitting. So the mean of the differences is greater than 0. So for paired data, instead of writing mu1 minus mu2, we just do mu d. So let's compare the strength of evidence to the earlier study design. We've got a larger t-statistic than we had before, and we have a smaller p-value than we had before. So if you have a larger t-statistic and a smaller p-value, that means that we have even stronger evidence this time, right? It was already pretty strong, but we have even stronger evidence that standing heart rates are higher on average. So this could be really important, especially if you have like a small sample size, something like that. It can be a lot easier to show what you're trying to show if you use a paired design as opposed to an independent groups design. So just sort of in general, paired tests tend to provide stronger evidence. And there's 2 main reasons for this. One is that each person serves as their own control, right? So we talked about how it's easier to see a difference when you're just comparing a person to themselves. The other is that, remember, we're taking 2 measurements per person here. So we're effectively getting more data because instead of having to split the people into 2 groups, having one group that's standing and one group that's sitting, we're getting data on everyone for both conditions. So we effectively have a larger sample size. So those 2 things together, you tend to end up with stronger evidence. So to summarize, we have 2 different designs for comparing means. The first one is an independent groups design where there are no connections between individuals in one group and individuals in another group. Each individual provides only one data value. And in that case, we're going to use what's called a 2-sample t-test. So we say 2 samples because the groups are independent, and this is a t-test because the response is quantitative, right? Number of beats per minute, that's a quantitative measurement. In a paired design, the data come in pairs. So there's multiple ways that we could get this. In the example we saw with heart rates, it was 2 observations on the same individual, and that's a common setup. But you could also have data from 2 similar individuals, So the example I have here, if you were trying to figure out whether garages make a difference for price, you might match up a bunch of houses. So you have houses that are similar in terms of square footage and that kind of thing, but one has a garage and one doesn't. You could also have data from two connected individuals. So if you looked at spending by a man and a woman who are in a domestic partnership, they live together, they have a lot of things that are in common, their income, they also might share finances, and so you would expect their spending to be the same in a lot of ways. And so then you're really just looking at the differences in men and how they spend versus how women spend. So it can be helpful to be comparing within households like this. So for paired data, the analysis is a t-test for paired data. And this is actually going to be very similar to what we did in Unit 7, where we were just doing a one sample t-test. Because basically what you're going to do is you start off by calculating the differences, just like we did in the heart rate example. So we're going to calculate a new column of differences, and then we're going to analyze just that column with a t-test. So at that point, it's basically just a one sample test because all you're using is that column of differences, and you can proceed just like you would in Unit 7.